Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday night, and this one is September the 28th, 2018, 9 o'clock in the evening. For those of us here in the eastern portion of North America, Universal Time, that would put us at Saturday morning, 1 o'clock in the morning, 2018, September the 29th again. So that means we are live, and our chat room is hopping, so come on over, and get any questions for us, type them in at our chat room, and I'm more than happy to try to answer them for them. How are you doing tonight, Nick?
I'm here. I did find 5 very good stories. Well, okay. 4 excellent stories and a really interesting twist.
Okay.
So yeah, it's cool. Been busy. Too busy.
Nice. Yeah.
I'm looking forward to a rest.
I had a few stories to go to and about different stuff. Let's see where we want to start out with. A little about the sun.
Yes.
Okay. That was the end of our sun story. Thank you very much.
Well, actually, saying that, I do have a very good sun story.
Oh, good, because the sun has no story right now, but go ahead.
Oh, yes, it does. It more than has a story.
Okay.
I got this story from spaceweather.com earlier today.
Okay.
It actually went out yesterday on their web server. The chill of solar minimum.
Oh, well, yeah, there you go. Okay.
So, as I say, basically, what's happening is the sun is entering one of the most deepest solar minima of the space age. Sunspots have been absent for most of this year, as most of us know, because basically Marty's not really been talking about the sun. There's nothing to talk about. It's just yellow blob. But however, the sun's ultraviolet output has sharply dropped. Mm-hmm. Now, new research is showing that the Earth's upper atmosphere is responding. According to Martin Milanakzik of Langley Research Center, NASA, we're beginning to see a cooling trend in the atmosphere. Now, high above the Earth's surface, near the edge of space, our atmosphere is losing heat energy. If the trend continues, it will soon set a record for the space age. Mm-hmm. Now, these results are coming from the SABRE instrument aboard NASA's TIME satellite. Now, what SABRE does, it actually looks at infrared emissions from carbon dioxide and nitric oxide, which also happen to be greenhouse gases. Anyway, the two actually play a real key role in the energy balance of the atmosphere at about 100 to 300 kilometers above the planetary surface. And by measuring the infrared glow of these molecules, SABRE can assess the thermal gas state at the very top of the atmosphere. It's a layer that's actually called the thermosphere. Mm-hmm. Sounds like something I take to work every day. Thermos.
There you go.
Anyway, the thermosphere always cools off during solar minima, and it's one of the most important ways the solar cycle affects our planet. Now, Martin is also the associate principal investigator for SABRE. When the thermosphere cools, it shrinks. So what it does, it literally decreases the radius of the Earth's atmosphere. This shrinkage decreases aerodynamic drag on satellites in low Earth orbit. It extends their lifetime. That's the good news. However, the bad news, it also delays the natural decay of space junk, result a more cluttered environment around the Earth. And there's a lovely little diagram there showing the various layers of the atmosphere and the temperatures. Now, to keep track of what's going on, Martin and his colleagues recently used what they called the Thermosphere Climate Index, CCL, minus. It's a number expressed in watts that shows how much heat nitrous oxide molecules are dumping into space. Now, during solar...
Pardon? That's no laughing matter.
Not really. Because Yeah, I know you were trying to make a dental joke there. Anyway, so during maximum TCI is high, it's hot. During minimum, it's low, it's cold. Right now, it is extremely low. In fact, Sabre is measuring 33 billion watts of infrared power from nitrous oxide. That's 10 times smaller than what we see during the more active phases of the solar cycle. Even though Sabre's only been up there for 17 years, they've been able to calculate TCI going all the way back to the 1940s. Now, Sabre taught them how to do this by revealing how TCI depends on other variables, one of which is geomagnetic activity and the sun's ultraviolet output, things that we've been measuring for decades. Now, they've actually got a graph showing the climate index for the thermosphere. And, well, you know what it looks like to me? It's like the old solar minimum and maximum butterfly diagrams. So this one starts in 1940, and it is projected forward to about 2020. So as this year comes to an end, the index is on the verge of setting a record cold. Not quite there yet, he says, but it could happen in a matter of months. Now think about this. We're actually going into Northern Hemisphere winter. And of course, the atmosphere is shrinking because of the lack of solar output. There's a lot of more energy being radiated out into space. So this can actually could potentially affect how cold our winters get. Now, what's going to happen at spaceweather.com, they're going to add the thermosphere climate index as a regular data feed. So you can, as well as all the usual stuff you can see about the sun, you'll start to be able to see this about the upper atmosphere state. And just as the researchers do, you can keep tuned in for the updates. Having said that, when you think about it, we're now beginning to really see what our star does to our atmosphere. Even though this is a 17-year-old instrument, it's still working wonderfully. And it's a 16-year record of the long-term changes that have happened. And this is an instrument that was only designed to last for 3 years. This goes to show we make them tough and we make them good these days.
Mm-hmm. Or less solar activity to zap our...
Well, yeah, there is that.
Satellites.
Whilst I think about it, Marty, I want to say hello to there's me and Marty in the chat room. There's Glenn, there's Recon, Starstorm, Evil Spot, Black Projects, Richie, and Quiet in the Wood. Nice to see you here.
In the quiet wood.
In the quiet wood, yes.
Mm-hmm. So Recon technically should be the Wrath of Khan.
Yeah.
The second appearance of Khan would be a Recon.
Yeah, or a reconnaissance. Yeah.
Mm-hmm.
So. Yeah, I know, Marty. I'm not really playing into your jokes tonight, am I? Well, not yet, anyway.
I think you're just not getting them.
Potato.
All right, so solar minimum, and we're showing evidence of the atmosphere shrinking because of that. And of course, doing solar minimum, we also have more cosmic particle radiation too, I believe, stuff like that. I'm not sure. I think so. Doing solar minimum because we don't have that. We don't have our atmosphere ballooned up and protecting us as much from cosmic radiation.
So the other thing, of course, though, maybe this can be seen as a plus, where there should be more red sprites to see.
That'd be interesting.
Well, if you think about it, red sprites are created by positrons in the atmosphere.
Okay.
And as I remember, and I could be wrong, I admit, I haven't looked into this for ages, a lot of this is caused and triggered by cosmic radiation.
Okay. Oh, we forgot to mention something. Sorry for the interrupted program. I know those of you that listening to the National Museum radio broadcast that we had going on, and we did kind of cut it off there for you, so sorry about that. We'll be getting it back again, or finishing the rest of it sometime. We will get it back for you, though.
But it is kind of interesting. We actually have a chance now to see what happens in a really deep solar minimum. Maybe we're heading towards a morning minimum. I don't know.
I don't know. You never know. The last solar minimum lasted a solid 2 years of no spots.
Yeah, and of course the other thing is given the galaxy of instruments that we have, which we can now use to look at the sun. We've got the Parker Solar Probe going there. Yeah. We've got stereo. We've got SOHO. We've got ground-based instruments. We have more capabilities of actually observing, and to actually watch the sun go through one of these minimums would definitely be useful information. In the old days, they had the ice fairs on the Thames because the ice was a foot thick. You could roast oxen. Thank you very much there, Black Project. Black Project has put a link into the chat room about red sprites.
Can't you hear solar flares when they happen, though?
Yes, you can. If you tune a radio to certain frequencies, you can actually hear solar flares as they're happening.
But generally, no solar flares during solar minimum.
Not normally, no. But our sun has been
possible, but generally, no.
But as I say, it's really a case of keep your eyes peeled. Being a G3 variable and your radio's on, being a G3 variable means our star isn't literally guaranteed to be a boring lump of gas. It is quite capable. Now, thank you very much, Starstorm. The sprite's red color comes from ions smashing into molecules in the atmosphere, similar to aurora. These particles excite nitrogen, hydrogen, and oxygen. So the gases eventually settle down and they release the energy, some of it into the form of pretty colors.
Never seen a sprite.
They've recorded them more, I think, from the space station.
Did they? Okay. Well, they've been obviously photographed from here on the Earth.
The thunderstorms too.
Well, I did see. I was looking for them actually about a week ago, as there was a thunderstorm kind of off in the distance. So I thought, well, take an eye. You know, it was kind of getting dark, so I kind of looked as much as I could and see if I could see anything sprayed up, but it didn't happen. But keep trying.
Well, you can always get a can of Sprite and.
There you go.
I got you.
Yeah, you did. All right. Now we're getting into it. Yeah, I did. I had some. There was a photograph. I took a couple of them. We're out observing one night here in Michigan and around the Detroit area, and Toronto was actually having a tremendous thunderstorm. It was like, turned out it was that far away, 200 miles away. So I went back. I gotta check. I checked a couple of my pictures that I took of that thunderstorm, and no sprites. Now, if something was going to have a sprite, that would have been it, because I was looking at this thunderstorm 200 miles away. That was pretty impressive, but no sprites. That would have been something if I could have gone back over my pictures and found some.
Yeah. But then again, one of the better ways to see these sprites is actually from the International Space Station.
Well, I can't get there right away.
They have a webcam on, don't they, pointing down to the Earth?
Well, maybe.
So there's a way for you to actually look for red sprites. Just keep an eye on the ISS webcam, and as it goes over a storm, start taking screen captures.
Well, we got two segues to go with this: space station or radio solar flares. Let's go radio solar flares, because I got something to segue into that one. Let me put this website into our chat room. I think you're going to like this one.
Lovely, more links is what I like to see.
Quite a bit on this one. Check this out. Would you like radio stuff?
Yep. Okay, so the International Project for Radio Meteor Observation. Yep, best time. A lot of it's done by radar, backscatter. And the thing is, with daylight showers, what better way to actually say, well, I've detected a meteor during the day, and always go, oh yeah, right. How can you do that? It's not dark. But I'm using radio. So
we happen to be peaking. Actually, we're peaking right now of a very minor meteor shower, but it does peak during the daytime. It's called the Sextantids. Yeah, so that's a constellation of sextants.
And of course, the other great thing is there's a French radar that is used to detect them, and you can do it at home using an FM radio. tune it to a very distant radio station, and every now and again, as the ionized trail goes through the atmosphere, the radio signal will be bounced to you. So you're not going to get to hear the whole show. You're going to get snippets.
Mm-hmm.
You may get a few beats or a little bit of music or a little bit of conversation. It will start and suddenly go. But if you're hearing that, that is because the signal's bouncing off a meteor.
Does it? Well, it probably matters what direction that radio station is. Does it?
Well, normally the way you do it is you point an aerial at into the general direction of the shower.
Okay.
So you're pointing a directional aerial towards the radiant.
Can you do that with an FM radio, though?
Yes, you can.
You can. Okay.
Think about it, Marty. You remember all the over-the-air TV antennas we used to have until cable and satellite took them all away.
Mm-hmm.
You can get them specifically built. You point them at your local transmitter.
Okay.
And therefore you can pick it up. So you can use it, and even more so if you're a radio amateur, because you can use 2 meters and 70 centimeters, and you can actually either try to bounce your own signals off, because you can be guaranteed there's going to be somebody out there. Now, a lot of radio amateurs have a bit of fun. It's called, I want to see who can get the furthest distance on VHF or UHF doing meteor scatter. So basically you're pointing it at a radiant, or roughly the area. If you see a tail, you point it at the tail, and you normally fire off a data packet, and you wait to see who the furthest person away is that's received it. Now, I believe one of the furthest records I know about was from Scotland into Romania, which is, you can't do it on voice. And the only way you can do it really on voice is if you have a satellite and you're using the transponders, which is done. Amateur radio has a lot of satellites up there for various things. You can do it. But with the idea this way is you ping a data packet. Someone will then capture that data packet. Normally it's done, sometimes it's done using Whisper, which is a mode, or JT, one of the JT protocols that was developed for radio amateurs to do mostly for Earth, really, in the beginning. Then it got used for more exotic modes, Meteor Scatter, Aurora Scatter. I think one person actually tried to bounce a signal off a rocket exhaust as it went by, as it went overhead on a launch, which is
is FM the best frequency? Some people have some especially older radios or newer radios, which you can actually pick up like television sound through your radio. Of course, there's all the different shortwave bands and stuff like that. But so, what would be the best frequency to tune?
Normally, it's done on FM.
On FM, okay.
Some of the radio amateurs will use either AM or sideband. If that particular, we're getting paged again.
Yeah, or distance record information for you there.
Yeah.
So FM would be the best frequency to get a station, and you're probably going to only get a station that's maybe like 100 miles away, approximately, something like that, instead of really far from a meteor, because the meteor, I think, is going to have to be fairly local.
Yeah. Now, I can't. Hang on a second. Let me switch screens, because I'm going to try and get into Skype on my phone so I can see the message we're being given.
All right. So I'm assuming that something that'll pick up something farther away, like AM, won't be good enough. So it's got to be fairly local meteor and local-ish, maybe just in the next area out of your FM range. So, for instance, I can pick up from Detroit area, northern Detroit. I can pick up Toledo, Ohio. It's about 50 miles or so.
Yeah.
So, but I could do that fairly easily. So it would be something a little farther than that, like 100 miles.
Okay, so
meteors,
theoretically, the communication paths between radio stations can be up to 1,400 miles apart.
Now, those are radio stations. What about like just regular FM stations?
I'm assuming that they took this. Hang on, let me just pull up the link that Black Projects has given us. generally, they're saying about between 30 and 50 megs. Most of us prefer to use 2 meters or 70 SEMS. The United States Department of Agriculture uses Meteor Scatter extensively in its Snowtail system. Snow gauges are equipped with radio transmitter that rely on Meteor Scatter to send measurements to a data center.
Mm-hmm.
I'm just trying to see. Single sideband has been popular via radio amateurs in the States, trying to establish contact with other stations. Oh, message from our director. We'll be replaying the American Museum of Natural History, December 5th of 2004, Space Chronicles with Neil deGrasse Tyson after a new talk in space tonight.
Okay.
And there's a link in there which I can't get, and Rob has given us some other links here from Southgate Arch in the UK on 144 Meteor Scatter record. I'm going to pull this up on my phone because I can't get to it. I don't know if you can see the message. You can put the link in.
I could get that. Yeah, give me a little bit to do it. All right. So anyways, so FM looks like to be about the best. And the distance that you're going to get a radio station from will be, well, we haven't confirmed that. How far away your little radio will pick up an FM station with bounce off a meteor. We'll have to confirm all that.
So, according to Southgate Amateur Radio, the one new 2 meter Meteor Scatter record was set between Fernando, Echo Alpha 8 Tango X-Ray, and Dita Delta Juliet 6 Alpha Golf on August the 6th of 2018. Now, the distance between the two stations is 3,428 kilometers. This exceeds by 51 kilometers the previous record.
I would assume that somebody broadcasting at a really high wattage, though, right?
They're probably using WSJT. Now, this was written expressively for Meteor Scatter Communications. And it was written by Joe Taylor, K1JT. And it's using digital signal processing techniques.
Okay.
So that is how they're doing that. Now, mostly WSJT is 2 meters and up. So it gets interesting. It's high-speed Meteor Scatter. It's normally just it's kind of what amateur radio was really about. It's all about experimentation.
Mm-hmm.
It was originally released in 2001, and as I say, it covers many protocols. So they've got JT65, JT6M, which is for 6 meters, but they reckon that the current record was set by a mixture of Meteor Scatter and tropospheric ducting.
Okay, I've got I pulled up a thing. Let me see if it actually will play for us. I think this is the sound of a meteor going overhead. Let's check and see what this will sound like here. That was listed as a earth-grazing fireball with radio reflection.
Okay, I've got another one here for you. This is described as the wailing cry of a meteor shower.
Okay.
I'll put this into chat. There you go. It is definitely spooky.
Uh-huh.
So now you do. Now you know what it sounds like. So what happens when a meteor crosses the atmosphere, it leaves behind a short trail of ionized particles, plasma.
Mm-hmm.
It reflects high-frequency radio signals from stations broadcasting around the world for just a few seconds. And the motion, obviously, of the meteor...
Sorry, go ahead.
What was that?
I was going to play your video, but it starts out with a commercial, of course.
Oh,
let me get past that. All right. Here we go. Well, it's like 5 minutes. We'll just give it a few 30 seconds or something like that.
It is it is. I agree with you. It is definitely very cool.
Mm-hmm. That was about 20 seconds worth there.
Yeah.
That's pretty cool.
It's 5 minutes long, and it is definitely very, very different.
Mm-hmm.
Now, as I say, I've done EME before, and I really want to get back into the really high frequency stuff. But to do that, you need big aerials, big space, and you're probably going to scare the neighbors because they're thinking suddenly that you are now part of what part of the NSA or GCHQ is now pointing aerials at my home, and are they beaming things into my mind?
Mm-hmm.
You get people like that. The Tin Hat Brigade.
Yeah.
Yes, quiet.
In the Quiet Wood said, I'm assuming it's the blippy noises that are the meteors. Yep, the basic static is static, and then when something comes in, that is the meteor. So you might hear like part of a radio station or something else like that.
But it is definitely fun to do.
Mm-hmm.
And of course, if you happen to be doing it around Halloween, you can probably scare the trick-or-treaters a little bit.
If anybody figures out what it is.
Well, yeah.
All right, a little astronomy and Halloween combined together. That's always fun. We'll get that next month, too.
Absolutely. Yeah.
I have to put together my scary radio program of what will kill you in space.
Yeah, we can do that again.
Mm-hmm.
Okay, so what else is going on? Well,
go ahead.
Well, I was going to go. I got a black hole story, actually.
Okay.
Got to have a black hole story. This is the Event Horizon, after all.
I know. I thought I had one too, but we'll see if we've got the same one.
Quite likely.
Okay.
I got this from astronomy.com. Matter clocked speeding towards a black hole at 30% of the speed of light.
Oh, different from what I had.
Yeah.
Good. Yep.
Okay, so there's the event. What they're seeing is providing evidence for how early supermassive black holes grew so fast.
Mm-hmm.
Normally, after passing the event horizon, which is the point of no return, boy, do we know about that one, don't we, Marty?
Yeah, that's right.
Nothing can escape. Whilst the depths of black holes may forever remain a mystery, unless, of course, we find a rotating black hole or we can find a way to get to the singularity and get out again, we can observe the regions around them. Now, in a paper published on the 3rd of September in the monthly notices of the Royal Astronomical Society, researchers have reported for the first time they have spotted a clump of matter falling directly into a distant black hole at nearly 1/3 the speed of light.
Mm-hmm.
Now, this is from observations from the XMM Newton X-ray Observatory, which is orbiting the planet, and it is of 40 million solar mass 40 million solar mass supermassive black hole at the center of the galaxy PG 211 plus 143. This is sounding more and more like Stargate every day.
Mm-hmm.
Okay, so it's about 1 billion light years away, and it's a Seyfert galaxy, which means it hosts a very bright, active feeding black hole at its center. It's pulling in dust and gas from its surroundings, and it's spreading the X-ray light received from the material out by wavelength. So researchers led by Ken Pounds at the University of Leicester clocked a clump of matter falling into this black hole at 30% the speed of light. That is about 56,000 miles per second, 90,000 kilometers a second. So they were able to follow an Earth-sized clump of matter for about a day as it pulled towards the black hole, accelerating it. It was being accelerated to 1/3 of the velocity of light before it crossed the event horizon and was swallowed.
Mm-hmm.
Now, peculiarly, there was the gas showed no rotation. It was not moving in the same way as the accretion disk, which shines around the black hole from its initial distance of only about 20 times the black hole's size when it was first spotted. So the traditional picture of a black hole, it has a compact, massive object at the center. It's surrounded by a disk of hot gas. Now, this arises from the fact that because black holes are so small compared to the mass they hold, infalling matter simply cannot cram into the black hole at once. Instead, it forms a swirling disk of matter, very much like water going down a drain. It approaches the black hole to fall in, and as the matter moves from the outer disk towards the event horizon, it loses gravitational potential energy, which is converted into radiation, which is what the radio astronomers can observe.
Mm-hmm.
So, in the traditional picture, the orbits of material inside the accretion disk are assumed to align with the spin of the disk of the black hole itself, forming one single disk. But this is where things are going wrong. The infalling matter is showing very little rotation, which is puzzling, at least until the introduction of recent computer models, also developed at the University of Leicester, run using the UK's Dirac supercomputer facility. There's another link. The Therium models consider the idea that matter can fall towards a black hole from any direction. Perhaps just instead of one disk, perhaps there are multiple misaligned accretion disks that form as the matter streams in. It can then tear away from those disks, forming rings of material that, if they collide, cancel out their rotation, which allows the material to flow directly into the black hole, just as has been observed. So there's a rather neat little diagram, example, infall from ring collisions. And it gives you an idea. Sorry, Marty?
So kind of like if you remember the movie Contact.
Yeah.
Remember the device that she sat in had kind of a multi-axis ring thing that in the middle of it was a chair?
Yeah, and you know what, Marty? You know where that device ended up as well?
Where?
In the very first few episodes of Eureka.
Did it?
Yeah. It was what Walter used that caused a tachyon burst, which was destroying time.
Yeah. It's also it was a kind of a thing that somebody invented, at multi-ring thing, and you would get in the center of it and start spinning around, multi-axis something or other. They used them at NASA, so some astronauts, and then kids would kind of get in them too. You can kind of get in it and start spinning around all different directions, and you wouldn't quite get so disoriented. But the black hole rings kind of resemble that thing, where it's not just one disk around the black hole, but some of them have multiple rings around the black hole.
And this is perhaps the greatest thing.
And not lined up. Yep.
If this is correct, this is a complete departure from what the previous models were assumed to be.
Mm-hmm.
Because we're so used to seeing, or perhaps inferring, a single accretion disk, and now it's perhaps more a chance of utter chaos in that particular vicinity, which would also perhaps be, dare I say the word, logical? So things have moved on. We've gone from Carl Schwarzschild's original mathematics, proving that black holes can exist, when he worked out the Schwarzschild radius, to the idea of, well, it started with the idea of dark stars. I think back in early France, just before the revolution, some of the dilettanti were speculating about, if we can have bright stars, why can't we have dark stars? Obviously, the dark star they were thinking about was what we now perhaps consider a black hole. Now, it shows you how things slowly evolve scientifically to the point now we have a misaligned warped outer disk, we have tearing regions, we have an aligned inner disk, and it is really a case of the slightest thing can change how the matter is perceived to fall in. And let's face it, the fact that we are clocking this matter at up to a third of the speed of light, it also has some very interesting implications cosmologically. Because I'm sure there's scientists out there thinking, well, if we can do this, if matter can do this falling into a black hole, does this mean there is a way we can invalidate general relativity and travel faster than light? So the implications perhaps for future scientists, maybe in the next 100, 150 years, if they can find out and figure out the mechanism, it might give us perhaps a more realistic chance at warp speed, perhaps.
That'd be nice. We could use that.
Yeah, it would be nice. Break out of the solar system.
There you go.
Explore the galaxy.
Quickly, not slowly, like Voyager.
No.
Well, let's do a little station identification. You're listening to the Event Horizon here on Astronomy.fm radio. It is another Friday evening, and this one happens to be September the 28th, 2018, about 9:30 in the evening for those of us here in the eastern portion of North America. So that would make it Universal Time 1:30 in the morning, Saturday morning, September the 29th. So we've got about another half hour programming to go through at live portion, actually. Then, of course, it will go into repeats with some more programming. And don't forget, we have our chat room open, so come on over and join us at astronomy.fm/chat. If you've got questions for us, we'll be more than happy to answer them for you. I want to say hi to everybody in chat so far. We've got you and me, Nick. We've got Glenn, Recon, Starstorm, Evil Spock, In the Quiet Wood, Richie, and Optronics. Welcome, everybody. Our international audience is here tonight.
Now, Richie has asked, how far from a black hole do you have to be to have a stable orbit? Well, as long as you stay away, as long as you are a fair distance from the event horizon. Once you cross the event horizon, there's no going back.
Well, that would be in a black hole. But outside the black hole
by that point,
as long as you're not disrupted by a third body, any type of, once you get into an orbit around a central mass, it's going to be pretty much a stable orbit. It could be highly elliptical or more circular, but it'll be a stable orbit unless you're just disrupted by something else.
Now, here, okay, you want some real, this is something I just found. So black holes behave the same as any other spherical collection of matter.
Mm-hmm.
Now, this is a conclusion of general relativity, but it's not a surprising result. Newtonian gravity, or classical gravity, states that any spherical symmetrical collection of matter will behave the same. This means that the radial distribution of the sun's mass doesn't affect its tug on the Earth. The vast majority of the sun's mass is contained below 1/4 of its visible radius, but if it was uniform, it would behave the same. So here is the math. And as I say, even I'm getting a headache looking at this. So I'm going to put this into chat room. See if you can make it. There you go. So that is the actual math.
Okay.
So good luck. I say even I would need at least a few days to get my head around this and say, yeah, I understand it. I have a good idea what they're talking about, and the biggest problem is keeping a position where you have sufficient energy, reaction, thrust, not to fall in. Mm-hmm. That is the biggest problem.
I think what they're saying is, if you're going to circle around a central mass, you really don't get relativistic distortion until you get kind of close to it, depending on how big the central mass is anyways.
So anyway, the important thing is a black hole is a relatively stable matter as far as a spaceship is concerned. The biggest issue, of course, is in a solar system, because you have planets, and the planets affect
the orbits
of
everything else.
They will affect your spacecraft.
Yep.
For example, when NASA was designing the Grand Tour for Voyager, they had to make sure that the solar system was at a certain point of alignment, so that they could go out. They could slingshot. They slingshot around the Earth, the Sun, Jupiter, Saturn, all in order to gain enough momentum to carry themselves out to the outer planets, to the ice giants, and then beyond. So solar systems They're great because you can use gravitational slingshot to move yourself on at a better speed than you could do with just a rocket engine alone.
Mm-hmm.
If you're with a black hole, you just need to make sure you've computed its diameter, you know what its Schwarzschild radius is, and you know where the event horizon is.
Yes.
And we know where the event horizon is. It's on Friday night, every week.
On astronomy.fm radio, that is
Absolutely
correct. Got a space station event happening here. Got a bit of a crew change, so we got people. Let's see, we got Expedition 56 is going to leave the space station on Thursday, October the 4th. So that would be, what is it? Expedition 56. Yep, will be departing at 3:30 in the morning, October the 3rd, Eastern Time. We'll be departing the space station, and I found out it's going to be landing 3 hours later, so that's basically only 1.5 orbits. So wherever the orbit, I think, intersects Kazakhstan, and then does 2 orbits, and then they come down after separation. So I kind of I'm trying to find an advanced track of how that will go, and I can't quite find it. So I always wanted to see the Soyuz capsule flying, but haven't been able to get the alignments to work right. So it's pretty fast come down. So sometimes they fly around for a day or so, but this one's like 3 hours. So it's basically 2 orbits, and then it's hitting the ground in Kazakhstan. So that's coming up.
Now, I'm sure here in the US, we are well used to encounters with wildlife out observing. Well, if you're an astronomer in the English Lake District, you have now got a new problem. Not only do you have to fight the clouds, the rain, the mist, now you have a cougar or puma on the loose in the southern lakes.
In the UK?
In the UK, yes.
Wow, because our one of our California astronomers, Aqua for You.
Yeah.
He has big reports of encountering cougars, but that's a normal cougar area in California where he's at. So, UK, what you got going on up there?
Well, basically, there's been a sighting of a large black cat, about 3'6" to 4 foot long, curved tail, 18 inches long. It's not the first big cat that's been spotted in the UK. That for years there've been talk of a mountain lion or a panther or whatever loose on Bodmin Moor. It was nicknamed the Beast of Bodmin, and every now and again they would find a mutilated sheep that had been well and truly noshed on.
Beware the moors.
Yes, beware the moors.
Beware the moors.
Now, the other thing, of course, is most people are so used to seeing lynx, which are wild, are small, slightly larger than your average domestic cat in the UK, because they're coming back in Scotland. So Scottish astronomers are well used to them, and they're mostly not interested. But this thing seems to be living off rabbits mostly at the moment.
And it seems to be larger than a lynx.
Oh yeah, it's much larger than a lynx. It's got they say that the eyes are the size of the old penny coins from the UK pre-decimalisation. So yeah, I agree. I think someone must have decided they got bored with keeping it and chucked it out.
So this is a non-native species then, right?
Right. Yes.
Okay.
Non-native. There's been people who've kept lions, tigers, leopards, and stuff, and most of them at the time they had a sense to ask a zoo to take it off their hands. But I suspect Glenn's right. Someone must have released it because they just got fed up with trying to feed it.
So lynx are normal in the UK?
Lynx, which are a form of native wildcat, yes.
Okay, so there's like 3 places you can find lynx. You can find them on the moors of England, or you can find them in our chat room or on our Facebook page.
Yeah, that's right. Now, the other story I found, which again is from astronomy.com, and it's another neutron star story. So we are kind of being very Event Horizon-ish tonight.
All right.
Now, and this is to do with a pulsar with an infrared emission. So what's going on? There's a strange neutron star. It's got an unusual heat signature, and it's an isolated neutron star. This is the first time they've seen it, and they're not sure what's causing it. This was published back on Thursday the 20th by Astronomy magazine. Now, most neutron stars are the end-stage remnants of massive stars, high-energy objects. They're usually studied at X-rays, and they're some of the most energetic light in the universe. They give off radio emissions as well, most famously as pulsars. Now, the Hubble Space Telescope has detected infrared emissions around a neutron star. It sparked curiosity, indicating that astronomers may want to start looking at their neutron star candidates with infrared as well. Now, infrared detectors are the night vision goggles of astronomy. These instruments pick up heat, which allows astronomers to punch through the dust, which is cool, and view objects like a hidden light, Sagittarius A. Now, you can get infrared light from some reprocessed emission or higher energy light that's been absorbed by dust, and then it's re-emitted at a longer wavelength. So, in a paper published on the September 17th in the Astrophysical Journal, a team of researchers reported the discovery of infrared emissions from the pulsar RxJ0806.4-4123. And before you go running off to your favorite remote telescope, you're not going to image it. Certainly not invisible light. Now, this one belongs to a group of 7 nearby X-ray pulsars. It's been nicknamed the Magnificent Seven. Gee, I wonder why. And that was in an article by Bettina Posset of Penn State, and she's the lead author of the paper. She said the Magnificent Seven are hotter than they ought to be. Chat room?
Yes.
I've been told we'll go back to the chat room a second. Hey?
Sure.
Yeah, Glenn says he's been told that... okay.
Panthers have been sighted.
Panthers, cougars, they're black. Or not black, Panthers are. Well, the thing is...
Some jaguars are too.
Some... Hang on a minute, I'm getting a comment here. Just 1 second.
There are some cougars that normally come in swampy areas that are so dark that they look black from a distance.
Okay. Now, I've just been told that if a cougar lives in a swampy area, it can appear to be very, very dark, very black in color. Mm-hmm. So it is theoretically possible. And let's face it, the Lake District hills are very boggy in places as well. So if it's living in that area, it is possible that it is genuine.
Especially if it's not a first generation.
Particularly if it's not a first generation, I'm told. So it is possible it could be a black puma or cougar.
Mm-hmm. I think there's been cougars spotted at high-end pubs in London, too.
Was that there?
Did you hear what I said?
I missed what you said.
I said cougars have been reported to have been spotted at high-end pubs around London also.
Now, Martin, we've got to keep it family-friendly.
That is family-friendly.
You're getting a dry chuckle from the chat room. Okay, so the only other story I have is Hayabusa.
Okay.
Back in the news.
Mm-hmm.
The rovers are doing wonderful.
JAXA, Japanese space agency.
Yep. So, okay, well, what is Hayabusa up to? So let's go have a look. The BBC reporting on this. And they've released some new images from the robot rovers. And it's showing new details about the surface of this space rock. It's called Ryugu. Mm-hmm. On the 21st, the mothership Hayabusa 2 released them. And Hayabusa 2 reached Ryugu in June after a 3.5-year journey. And it gives a very clear relief picture of the rugged, boulder-strewn landscape of this striking solar system body. So the robots are known as Rover 1A and Rover 1B. They're both confirmed to be working. And the 1 kilogram autonomous rovers move about by hopping. Using the asteroid's low gravity, each one contains a motor-powered internal mass that rotates to generate force, propelling the robot across the surface. And there are some really good pictures attached to the report. And of course, there's also a video, the very first video footage on the surface of an asteroid sent back by Rover 1B.
It definitely looks like a rubble pile type of asteroid.
Oh, yes.
Every picture has just got smaller and smaller pebbles all over the things. It's kind of like looking into a rock quarry or something like that.
Well, that has been one of the things, and that's long been thought about some of these asteroids. That in fact they're nothing but conglomerations of rubble held together by their own gravity.
Which is not much, which is kind of interesting.
Not much, but it's sufficient to bring them together and keep them together in one place. Obviously, until something smacks them hard.
Yep.
And then
not going to have anything like a wind going through there.
No, I'm more thinking of perhaps another piece of space debris that was perturbed, had its orbit perturbed. You've got to remember, these rocks are in an orbit between Mars and Jupiter. So Jupiter does cause perturbations of the asteroid belt, as does Mars. So anything, and particularly if a comet was to come through, that too could also disrupt the conglomerate of rubble.
Interesting if they could figure out what's given it that original shape, that kind of like a diamond shape to it.
Probably the way it's spinning.
You think it'd either be totally random or a little bit circular, but it's not. It's semicircular, but more like diamond-y shape. So that's pretty weird.
But as I say, there's now stranger than stuff on the heaven and earth, Horatio. Sorry, I had to go there.
It would be really cool if they could smash something into that one. Maybe they'll send another mission to it and smash something fairly sizable into it and see how it reacts. If you put sensors around it and see if they pick up, like quakes through it. Well, quakes obviously are really good for determining the internal composition of something like that. So that would be pretty good if they could scatter a bunch of sensors all over the thing and then smash a part of a satellite into it. That would be some really interesting data to be able to figure out what's inside it. And especially might even be able to catch some shaking and the rocks and pebbles moving around and stuff like that. That'd be kind of interesting.
Well, as I say, of course, you're going to have, I'm sure everybody remembers the Sean Connery film, Meteor.
I don't remember that.
You don't remember Meteor?
No.
It was only the best film on the subject.
Okay.
I'm sorry, even today, it makes Armageddon look stupid.
Maybe that's why I remember Armageddon, because it was more stupid.
Yeah. But Optronis said you don't want to encounter a puma. I've encountered a timber wolf. That was interesting enough. So who knows? Hey, here, kitty, 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 kitty.
As long as you're not hungry, it's okay.
No.
Yeah. Let's see. Did I have something else from NASA? I don't think so. Oh, Opportunity. They've actually spotted it.
Yeah.
From the MRO satellite circling around it, so they know it's there. The air is clear enough to spot it, but they still haven't got any contact of it. So, not good. But hopefully something will happen in a good way. But so far, not happening. So there's images of it from orbit.
Now, Quiet in the Wood has said, I hate to say it, I think Armageddon was kind of dumb. It was kind of dumb. Let's face it. Going to a big chunk of rock that's heading towards your planet to smack into it, and then planting nuclear charges, what you've just now created is a huge chunk of shrapnel. So you're going to do even more damage. Now, the theory behind the Meteor film was using nuclear detonations in space, not actually detonating the nukes on the rock, to push it into a new orbit, to push it away. And I think that's probably, even for the late 1970s, that was a pretty good idea.
I don't know about that. Like I said, nukes really need an atmosphere to be functional. So if you just put a nuke on the surface of a asteroid, you're not going to get that much push out of the other way because there's just no atmosphere. Basically, you need something like a rocket engine.
Yeah.
So exploding a nuke in space, you don't get that. You don't get the air expanding. So it doesn't move anything.
It's still one of the few ideas from the old days that's got relative merit. But as I say, it sure as hell beats turning it into shrapnel. And then expanding the damage area. And you know what, there's nothing wrong with being a cranky old science-minded geek. Guess what? Martyrs, I am My daughter definitely is when it
I
suits
was
her.
about to say something.
Go.
Now I could say like it.
There might not have been actual science considered
Yeah,
when
I
they
think.
made that.
Yeah, there you go.
I know it was a love story. Okay.
It's more of a case of, hey, we've got this. Why not do this?
Something like in Armageddon, instead of exploding it out, if you could actually, bury it in a pit and loosely put rubble on top of it, and then explode it, so that stuff shooting out of the pit would actually be enough, action reaction. That would work like a particle engine, and that would actually blow it in the opposite direction, depending on how much particle stuff was actually shooting out of the pit. So that would be possible. Maybe not exploding it apart, but actually, getting stuff to shoot out of the pit. But you would have to bury it and then cover it with lighter material than what's surrounding it, so it wouldn't break up. So yeah, your engine has to hold up in order to be able to shoot something out the other end of it. Now, that would be more possible.
Strap an engine to it, set it off, push it out.
Mm-hmm. Yep, I always thought about that. So basically, it's an engine that's upside down. So, like, you ever see those when they test rocket engine on a test stand?
Oh, yeah.
They shoot it sideways. Well, technically, that's changing the rotation of the Earth. A very small amount, but it would be. So depending on which way you pointed it, if you pointed it towards the east, you're technically increasing the Earth's rotation. Point towards the west, you're decreasing the Earth's rotation. Well, the mass difference between the two is very, very negligible, but smaller the object you put that rocket engine on, basically to push it as an engine, you'd have to point your rocket engine, the nozzle would be pointing up. And
Glenn has just put a link into the chat room.
Okay.
He's going back to our Puma on the loose in the lakes. And it's a picture of a cat standing up to a mountain lion with a glass door between it.
I missed a International Space Station crossing tonight. Well, there's two of them tonight, actually. One at 8 o'clock and one at 10 o'clock a little while ago. Oh, no, coming up. 9:52, 4 minutes ago. Flew over. Well, didn't get a chance to see it. Let's see, a couple other objects. Let's see. Bright star occultations. Got one coming up on the 30th. The moon's going to go in front of a star, fourth magnitude star in Taurus, but that'll be visible from Central South America. So that's one for optronics to look at.
Yep.
Alert notice. So we got to do this one for everybody out there. From the AAVSO, alert notice 651. They want to monitor a star called T. Pix, what's that? Constantly Pixis, I think it is, something like that. Southern Hemisphere, approximately 9 hours right ascension, declination minus 32 degrees. They're going to be pointing the Hubble Space Telescope at the star. It's a cataclysmic variable star. They want to observe it while it's really at quiet, because they're going to use some super sensitive instruments on it, so they don't want to point the Hubble Space Telescope at it when it's in outburst. Normally about 15th magnitude, and it gets as bright as 6th magnitude. So that would be a great one for somebody with any size telescope to see this project. So basically somewhere around the equator of the Earth to southern hemisphere for this one. Just point your telescope on it, and if you see something, it's an outburst. Even if it gets to 14th magnitude, it's an outburst. Report that information, and that will actually save the Hubble Space Telescope. Well, they will just avoid pointing at it. I'll put that link into our chat room. So yes, you can actually help a scientific project by doing something like this.
There's a lot of things you can do that help scientific projects. Not all of them need a telescope, but most of them do. And to be honest, this is a fun one to do. Is just to actually plot it for yourself. Okay, Marty, I think it's time that you, me, and Starstorm started putting all our kit away.
I think it's about that time.
Yeah, it's about that time, but the music's playing, I'm told. So I guess really all I have to say now is, Captain Savick, this is the away team. 3 to beam up. Thank you for listening, everyone. I'm glad hope you enjoyed the show, and nice to see you in chat.
Thanks,
Good night,
everybody.
Everyone.
thanks. Appreciate everybody being here tonight. Yeah, we got about 30 seconds to go. So, from what I can tell. So, all right. We'll be back again next Friday. I won't be. Will I be here next Friday the 5th? I won't be here next Friday the 5th. I'll be out of town for that one. So, you'll either Nick will have a co-host or do a repeat then. So,
we'll see what happens. I'll put the word out.
All right. Thanks,
Energize.
Everybody. We're out of here.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing. And all of a sudden, wham! Astronomy right between the eyes.